Hey guys, my name is Anas Abuzayed and welcome to the second lecture of this course of energy system analysis. Today we will be talking about the data structure. So previously we talked about the data types, integers or strings, floats, complexes, booleans, and so on. Today we will go a bit further where we talk about the data structure. So in Python, we have four types, let's say, of internal data structures. One of them, or let's say the most common one of them, is a list. So the list or a list is basically a collection of data types or of data entries that is ordered. So you can order it from 0 to 10, let's say. So in Python, we start always with 0, not with 1. And these are changeable. Also, it allows for duplicate numbers. So we will go through details of what exactly this means. We have another data structure type, which is a tuple. It's again another collection of values or of data types, data entries that is ordered but not changeable or unchangeable. And it allows for duplicate numbers. We have another one, which is a set. So it's a collection of unordered and unindexed values, and no duplicate numbers can be found. And finally, a dictionary or a dictionary, where it's a collection of data types that is ordered and changeable, no duplicate numbers, duplicate entries or members are allowed. We will go in the details or through the details of what exactly this means. So as we did previously, we said always, so I always like to start with, let's say, A equals something, so that I see it in the variable explorer. So how can you define a list is by the closed brackets. So something like this is a list. So if you say, for example, A is a list of 1, 2, and 3. So it's a list of 3 values or of 3 entries that are 1, 2, and 3. So we said A is a list of 1, 2, and 3. So it means it has 3 elements. Those elements can be either strings or floats or anything. So you can say is a string of the first element, let's say, is 15. The second element is letter B. The third element is a Boolean, 2, and the fourth element, let's say, is 1.5. So again, A is a list here of 4 types or 4 entries of data. Each one of them can have its own value or its own even type. They are ordered. They can have even duplicate numbers. So for example, we can say 15. So here A has 15, has 5 types or 5 elements, and they can be duplicates. So it's not a problem here. One important thing about lists is how you can access them. So it's very important to know how to access data. You will have during the course, when we go further down, lots of types of data or lots of lists, let's say, where you might store your own data in to later export them. So it's very important to know how to access them. If you want to do mathematical operation on them, if you want to plot them, or if you want to use them in a model or whatever, you need to know how to access them. So how to access it? Now we have A as a list. Let's say we want to access this element, the true one, so the third one. If we say A with a bracket of 3, so how to access it is using this bracket. A of 3 is basically 1.5. So why is that? Because in Python, we start counting from 0. So this is element 0, element 1, element 2, element 3, and element 4. So A of 0 is 15. In this case, if we want to access the true, or let's say the third one, it's A of 2. If you say they are, so it has a size of 5 here, you can see it. And if you say A of 5, it will give you basically an error because it's out of range, even though it has 5. But again, as we said, we start from 0 in Python. So it's very important to know that if you do that, you will get an error. Another cool trick here is if you want, let's say, the elements from true to the end. So if you do it like this, 0, 1, 2, so from 2 to the end, it will give you true, 1.5, and 15. Let's maybe have a bigger list so that we can have a bit of flexibility around it. So let's say we have this one, 45, and then 4.2, and then D, and then another string, let's say of 88. So here it's a string, not a number. And let's put a name. Let's put my name. So now we have a size of 10. So we said we want from true to the end. So from true to the end, it will give us basically a split, or let's say a section of that list. If we want to say from, let's say, one element to another element, so let's say from 2 to 7, so it will give you the second, third, fourth, fifth, and sixth, not including the seventh. So the D in this case, the string here, the seventh element, will not be included. Another also kind of, or let's say method of selection is using the negative. So let's say -1 in this case, it will be the last one. So either access it, start counting from here, but you count from 0, or you count from here from -1. So in this case, if we say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, so A of -10 should give us A of 0. In this case, as in the previous lecture, if we want to compare them, then it will give us a true. That's good. Now we know at least how to access the list. Let's see if we said previously that they are changeable. So we can't change them. They are ordered. So A of 0 is this one. A of 2 is this one. So they have an index. They are ordered. Or let's say they have an index. They are indexed. Now let's see if we want to change them. We said that they are changeable. So let's say we want to go to this 88 and make it as an integer. So for those watching, try to pause the video and think about the solution. What could be a possible solution for this? So I want the same list here, but with this 88 as an integer. How can I do that? So we have two methods here, how to do it. So either I say 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8, sorry, A of 8 is 88. I want to, sorry, equals, I want to make it as an integer or as a float, whatever you want. In this case, A is, now it's 88. So this is a number now. Another method that we can use is by having the negative counting. So -1, -2. So A of -2 or -2. Now it's already an integer, but we can say, okay, it's an integer of A to the -2. So this one, or let's maybe do it as a float. So that we can see the change actually. So A now, we see that this is now as a float. So now we know how to access it. We know how to change, or let's say how to access the list, how to change it. Let's see what other things could be also done to the list. So if we want to say A, what is A? And we want to add a new element to it. So let's say we want to add, we have Anas here. Let's say we have 1 million next to it. So if we want to add another item to it, we use the function append, sorry. So a dot append, here you can say anything. So if you want to have a number, so 1 million, now you have the last element as the new number that you entered, or the new elements that you entered, or the new, let's say, data that you entered, and it's always in the end. So if we want to add another thing, let's say a dot append, sorry, false. So now we have another one, which is false. Let's say we have two lists. For example, we have B, for example, of X, Y, Z, and oh, sorry, we have Y already. and let's say of C. So this is another list, and we want to add the two lists next to each other. So we can say A dot extend B. In this case, we have those elements added to A. So now it's a longer one. You can see it in one line. So now it added the new or the elements of the list B to the list A. One other thing, for example, let's say we add an element of, I put my name in capital, say I put my name in small. So now we have A, it does have, let's say my name twice, but one is capitalized, one is not. So those are, let's say, functions that are with the things that I will show now that are functions with strings. They don't have anything to do with list, but I thought maybe I show them here. So let's say A of -1, this will give us the last element. So if I want to have the capitalized, or let's say the capitalized version of it, so capitalize. Here another tip. For example, I did not write capitalize all of it. I just said cap, and then it gave me kind of a suggestion. Just press tab, and then you will have it. So it will give you, or will print out the capitalized version of it. Does this mean that A is now has the last element as a capital version of my name? Let's check. No, it's not the case. Why? Because we did not assign it. So we need to say A of the last element. So this last element equals its version or its capitalized capitalized version, sorry, of it. Now let's check it. Now we have it capitalized. Another useful function is, for example, let's say again my name. So A -1, the last version, dot lower. This gives you the lowercase of this string, or A of -1 dot upper. This gives you the uppercase of this name or of this string. So any string, basically Python deals with it as a string, not really as a name. So we talked about how to add it, how to access it, how to change a bit in it. Now let's see if can count it. So A as a list, for example, what are the things that could be duplicate here is basically the string of my name. So if we say a.count, and then you enter anything here, let's say 1.5, it gives you a count of 1. Why? Because there is only one element of 1.5 or of this value in there. Let's say a.count 50. So it doesn't have any element of 50 in there. But if we say a.count and then just put my name, here it's 2. Let's go back, for example, to where we tried to put my name and capitalized. So we want to make it as lower. So check A again. So although it's the same name, but because it's a sensitive case, one is capital, one is small. Let's check again. Now it's a count of 1 because one is capital A, one is small a. So this is also very important when you deal with data, even though they might seem the same or look the same or even spell the same, but their capital or lower cases or upper cases might differ. So this is very important. Sometimes when you compare data, it might be a good idea to use this dot lower or dot upper just to make sure that they are always the same. So if I say A of -1, which is a small case, and this one is, let's see how we can access it. So -1, 2, 3, 4, 5, 6, 7, 8. So A of -8. Does this equal to A of -8, which is capital, and this is the small one? So it's not the case. You saw previously that when I wanted to access this one, I started counting. So either you count from the beginning, 0, 1, 2, 3, till you reach 8, or from the end with -1, -2, starting from -1. There is another feature in the list that you can basically see the index. So A dot index of, let's say, B. It will give you the index of it. So again, go to A. This is the index of B, which is 0, 1. So B is 1. Let's say we want to access this one and see what is the index of it. So now it's 9. Let's see this one. So again, so it's -8, which is 9 in this case, but it doesn't mean that it's -8, -9. It's only because it's 17 elements in it. So in this case, the index of Anas or of the string Anas was 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, or from the end -8. So let's say A dot index of C. This will give us 15. So when you have a bigger list, let's say you have a list of 200 or 300 and you want this value, what's the index of it? Let's say, as an example, times where you have this element that happened, or let's say was appended in that list. So instead of counting them or checking them manually, you can do something like this just to get the index. Let's try another thing. So now we have A that has, let's say, those two elements. So again, we want to make it capital, just not to be redundant. So now we have the two elements. Let's say I put A.index and Anas. It will not give me this one. It will give me the first time that this element basically happened. So even though it's duplicate, you can see here A.count. So it happened twice, but it's only, or it will only retain the index of the first one of them. So now the last thing we learn about the lists, of course, during the course you will learn more about it, but let's say the basics of it is how to remove something out of the list. So let's say we want to remove my name. So A dot remove, and then just put A. Now let's see it. Which one do you think was removed? Again, the same one, or the first one that popped up. So between 88 and 1 million here, we have this type, or this value of my name, my string, or let's say the string of my name. So it was removed. Another one is if you want to remove a certain element. Let's say, for example, we want to remove this one, the million. So either I count the index or I say A.index, this one. So it's the index of 9. And then I say del A of 9. So again, A now, so it became a smaller list. So you see it now next to each other. So this 1 million is gone. Another one is A dot pop. So this will basically pop out the last element. So if you go back to A, previously it was 15 elements with my name, sorry, my string as the last one of them. Now you see it as a list of 14 elements, and it popped out the last element out of it. Let's say we want to clear it. So we learned from the previous one, we can basically clear it by clicking out or by deleting all the variables here. Or another way would be A.clear. So it will basically not remove the element itself, but clear it. So now A does not have any elements. If you say A of 0, it's out of range. So it's already gone. And delete A, sorry, will basically even remove it as a variable. So those are the, let's say, the basics of the list. Now we move to the next type of elements or next type of data structures, which is set. So you will see during the course that I use list a lot and dictionary sometimes also a lot. And I rarely use tuples or sets, but I use them. So I thought maybe I put them here with a bit of introduction. How can they be used? What's the difference between the 4 types of data structures, the internal data structure, sorry, in Python? And then from there, it depends basically on you, what you like to use and how you use it. So there's no really rule of thumb here. So when we talk about a set, we said previously that it is a collection of data types or of values that are ordered unindexed, and it does not allow any duplicates in there. So let's just do it like this. Let's move this one first. Okay. So how can we define a set? Previously in the list, you basically do a closed brackets like this. In a set, you use the curly brackets. So this is how you define a set. So if you say, for example, let's say text equals, so technology example for generation. So let's say solar and on wind. Now it is a set. We will talk later how can we create a dictionary also with the curly brackets, and how exactly what's the difference between this and that. Another way to create a set is by saying, okay, set, and then you put solar and on wind. So it's the same. Yeah, so you use text. Let's keep it. It's not a worry. So how can we, let's say we want to access it or we want to deal with it. So if you say text and zero, it's basically not subscriptable. So it means because we said it's unindexed, so you cannot really access it using the same way that you used when you did with a list. So basically, a set cannot be accessed. So if you want to access, let's say, the second element in it, it is impossible. Um, of course, you see here, for example, that we said solar as the first element, on wind is the second element. If you print it down or if you put it out, it is ordered alphabetically. So on wind is first, solar is second. We will learn later on how to access it using a loop. But for now, basically, you cannot really access it or access elements in it. Of course, like the list, you can add different types of data. So how can you add data to a set? Say text dot add, and then let's say we add a number 5. So here we can see it now if we add it. Let me just remove that quickly so that we now, so 5, a number is first, then on wind, and then on solar. Or sorry, solar. Let's add another technology, for example, let's say text dot add, not append. Let's say hydro. So now we have 3 technologies, of course, with the number. It's okay. If we want to add certain elements, or let's say a bunch of elements, so let's say text dot we want to add another set to it or another bunch of elements, so not only one element, then we use update. So in update, either we use a list, let's say again, we use, let's say battery, hydrogen, and hydro. So run it. Ideally, we should have a duplicate because we have hydro twice here. If you print it out, text, it will not allow any duplicate numbers. So just in case, let's say for the future, when we start analyzing real data or power plants data or so on, if you want unique data out of it, you should consider using a set. Why? Because it will not allow any duplicates, just in case. Let's say you have different types of CO2 carriers, or so to say CO2 emission carriers, or different carriers, and you want only the unique parts of it. So you, in this case, you would consider using a set because it will not allow for duplicates. Another thing that you can use, let's say text dot update. So you can add, as we said, a list. Let's just put CCGT, so combined cycle gas turbine, and OCGT, open cycle. And we can add again another set to it. So let's say off wind and on wind and ROR. So in this case, we would expect CCGT and OCGT to be added, off wind, of course, to be added, and run of river. On wind will not be added because it's already there. So if we say, or run this one, Now we have it as we expected that wind will not be added. So now it's a set with a size of 10. So say we want to remove data. We cannot access it. So we said previously, if we say text dot zero, which is ideally, if it's a list, it should be the first element. We cannot access it, but we can remove it because, as we said previously, it's a unique set of elements. So let's say we want to remove CCGT. So we have two ways to do it. So either by using this card and then just putting CCGT, or yeah, we said CCGT, then it will be removed. You see it now, it's a size of 10. Let's just remove the 5 just in case. So we said using discard or using remove. What is the difference between them? Let's try to remove OCGT, so all the non-renewable ones. Now, we don't have OCGT or CCGT between them. What is the difference? Let's try to run the code again. So although we don't have CCGT in our set, if we run it, it will not give us any error. But if we use remove and OCGT is not already in the set, this would give us an error. Basically a key error because it did not find any element in there with the value of OCGT. So beware that you might use discard instead of remove and so on. So since we discussed removing elements out of it, of course, the same thing would happen with, or as we did previously with pop. So if you go to text before we execute it, so in this case, basically it popped out on wind in this case. Let's say we do it again, text.pop. So it will basically pop out an element out of it. If we say, or we want to clear it, so text.clear, it will give us an empty set. So one last thing about the text before we, oh sorry, about the sets before we move on to the to other types. So let's say one set is equal solar, wind, and then let's say coal and CCGT, and text or tech2 is solar, let's say the cool thing about sets is that you can do the union of them or the intersection between the two sets. So if you say tech1 and then this one here and tech2, it will give you the union of both. So again, there's no duplicate. So you will expect solar, on wind, coal, and CCGT to be there. Since solar is already there, you will not expect it. Off wind, not there. Sorry, solar is there, you will not expect it to happen or to show up. The only new element is basically off wind. So those four plus the off wind is the union of both. Of course, there is union, and then you say tech two, and the same thing would be tech two and union with tech one. So they will all give the same results. One other thing is the intersection. So the intersection between two sets is using, so take one and take two. Just zoom out a bit. Is basically the intersection of both and intersection here and there. So this basically is the intersection of both, or basically the duplicates between both. So solar, on wind, and coal exist in both sets. The last thing is basically, let's say, the differentiation or the difference between both. So tech one minus tech two will basically give you CCGT, which is the one element that does not exist in tech two. And vice versa, if we say tech two minus tech one, this would give us off wind. So what are the elements of tech two that do not exist in tech one? In this case, it's off wind. So from here, We will not discuss sets more. Of course, there is lots of literature, lots of good videos, good explanation on it. As I said, we don't quite use it often. Also, the same case with the tuples that we will discuss now. Tuples will be quite quick, I would say. So we said previously, tuples are a collection of data that is ordered but not or unchangeable, and it allows duplicate numbers. Because of the fact that it is unchangeable, it might be not as useful as other types of data, but again, it depends on the application that you will use it. To define it is using the parentheses. So like this. It allows duplicate entries, different types of entries, so a string or integer or float or even a Boolean. Let's just do it. A tuple is information on a power plant. So this is called solar power plant, for example. It was built in 2018 and it has 500 megawatts of capacity. And let's say the location is, let's say Heidelberg. And let's say true equals that it receives subsidies, something very random. So now we have a tuple. How we access it is the same as with the list. So A of 0 is basically solar, so the same thing. A of -2 is the second last element of it. The issue here is that we cannot really change it. So let's say in case we said it receives subsidy. So let's say that we want to change that and we say, okay, A of -1, the last one, we want to make it false. And if you try to run this one, it basically does not support assignment or changing of its items. The last part of data structures that we will discuss in this lecture is dictionaries. Let me just move this one here. So we said previously that we have a tuple with solar power plant that was commissioned in 2018 with 500 megawatts, and it's located in Heidelberg with through as for subsidies or something like this. For dictionaries, I find them the most, let's say, the coolest parts of built-in data structures in Python because it allows you to have separate data sets within each dictionary. So let's start very simple. How can we do it is with the curly brackets. We saw that previously with the sets. What is the difference here? When we define a set, we use the curly brackets, and then we put the elements here. So we said, let's say solar and on wind or whatever it is. Now it's a set. So what is the difference here is that in dictionaries, you have something called keys. So let's start very simple. Let's say A equals brackets. So here we define a key. For example, let's say carrier. And then what is the value of this carrier? Solar. So this is one key. What is this key? It's called carrier. That's why we use double points, not commas, as we did in the sets. Let's say this is the first key. The second key would be something like we said commissioned and then 2018. For that. Again, another key. And in this one, we say, okay, P nom, so nominal power is 500. Is location. In this case, we said Heidelberg. And finally, let's say subsidy. So let's try to run it and see. Now we have basically a dictionary of data that has different keys. So how can I say it or how can I access A keys? This gives you the keys. So you can have different power plants, say for example, in this case, or different data entries. where you have one key and different values for each. So let's say the first entry would be the carrier, in this case, the carrier for the first power plant, and then the carrier for the second power plant, and the carrier for the third power plant, and so on. Then you move to the next key, which is the commission year or commissioned in this case, and which year for which power plant, and so on. So if you want to access, let's say, um, the carrier, let's say we want to go inside the key carrier. So same thing as the list that we did before, but not with numbers. If we do it a.0, it should be 0 because it's the first key. It will give you an error. So how can I access it? Is by saying, putting the exact sensitive case key value. So in this case, it's carrier, so it should be the same. So A of carrier is basically solar. So that's a very nice way how to organize data if you want, or if you have a big set of data, sorry, that you want to somehow organize in a nicer way, or you have different, let's say, data entries that you want to separate somehow, you can also use it. And it's very useful. Of course, you can change it. So let's say we had the first one to be solar. Let's say, yeah, it's not really realistic. Let's say that Pnom was 500, then they expanded their power plant somehow. So Pnom is 500. We want to make it 700. So they added 200 on top of it. So now if you open it again, it's already 700. That's already very useful. So you can basically change it. You can do whatever you want with it. Let's say we want to have different power plants. So let's say we have 5 power plants, 5 commissioning gears, 5 nominal powers, 5 different locations, and different status for subsidies or receiving subsidies. So there is 2 ways to do it. Imagine yourself working, let's say, with a normal sheet, and you want to have 5 entries with 5 columns for carrier, commission, nominal power, location, and subsidy, where each one you enter its own value. So this is possible with a dict or with a dictionary. How to create it, either by using a list or by doing a dictionary. We will do both now just to show you what can be done with a dictionary. Of course, later on in the course, we will use dictionary quite often, also the case with lists, unlike sets or tuples where I don't really use them quite often. So let's say we have different carriers. So carriers, I just want to define a list, say solar, on wind, off wind, and then OCGT, and then let's say battery. Not really battery, let's say RR. So we have a list now of 5 elements for carriers. Let's do the same for years. So I just want to say years. I can just say X instead of carriers. I just use it. I like to use names that make sense because when I debug my code, at least, okay, it makes sense for me. I can use X and then use it later on with a dict or with a dictionary. When I define the keys, it's not really an issue. So 2018, 2019, 2020, and 2017, let's say, and 2005, something like this. So we have now nominal power. So P. The nominal power will be basically a list of numbers, of course. It can be a list of anything. So in dictionaries, we saw previously that you can either use a string or number, even a float if you want. So it's not really anything. So A here, it's already a float, or a Boolean or a string, so it's nothing. So it can be that P here is not really an actual or real number. It can be anything. So P, let's say for solar is 220 megawatts. For wind, it's 700 megawatts, 1500 for the off wind, 2000 for the OCGT, and 4000 for the remote power. Just random numbers. Now we want to make a list for locations, so logs, and then I say, okay, let's just use different cities. So Heidelberg, and then Berlin, and then München, and of course, Offenburg. So let's say subsidies, so another last list, let's say subs, and then we say, okay, just trying to be logically, so true for solar, true for on wind, true for off wind, and then false for the last two. So I'm just creating 5 lists that I want to enter there later on within my dictionary. So how can I do it? The same thing I did here. Instead of adding one entry, I'll just add the list. So instead of saying carrier equals solar, then I say carrier equals carriers. So this one here. Instead of 2018, I'll just use years, which is the same one here. And then P, and then here logs, and then subs. So what really happens now is that we have, if we open A, you have a dictionary of your power plants where you have different, for example, if you want to say, okay, what is my first power plant? Let's say A of, we said carrier, and then it's basically a list here. So how you access it is depending on how you define it. So if this was, for example, a tuple, not a list, you cannot really access it. So here it's a list. How we access list is using the brackets, the closed brackets here, so you can access it. Let's say we are now here. So how can we change this one here? It's a list, so we can change it. So whatever you define it inside the dictionary does not relate to the dictionary itself. So you can have, for example, let's say this one here is not basically a list. Later on, we might have it as a data frame, a pandas data frame, something like this. We will learn this later on in the course. So how you access it depends on the behavior, or let's say the nature of how you defined it. So we defined it as a list, that's how we access it. So this is the first, let's say, way how to create this one, let's say, or how to create different power plants with their informations, save them somehow, maybe iterate over them later on in the course. How when we learn more about the loops, we will do this in the next lecture. But it's basically a very useful tool to use the dictionary. Another way how to use it is, let's say we have 5 different power plants. So let's say we define power one, or let's say PP1, power plant one, equals a dictionary. So in this dictionary, I want to have different keys for carriers, years, P, logs, and subs. And in each one, I put the data for this power plant. So let's do it as we did before. So carrier, and then I say, okay, so that's the first key. So if I just define it, PP1, it has one carrier, sorry, one key that is, its name is carrier, and its value is solar. So let's do it. Just put random numbers. They don't need to be identical. And then the last, oh, sorry, the next one is pnom, let's say 800. And then location, let's say we use the same Heidelberg. And then lastly, subsidy. And then true. So now this is power plant one that has different keys. Let's create 5 different power plants and then add them all in one dictionary, or let's say a dictionary of power plant, just so that I can show all of them together. And now we have defined the 4 different power plants. And what I want to do is basically have a dictionary of power plants where I want to have a key for each power plant, where if you access that one, you get information only on that one. Here you saw it previously that if you want, for example, to know the off wind, what is its data, then you say, okay, it's the third element, then you need to go to the third element in this key, the third element in this key, and the third element in this key, and the third element in this key, just to know its specific data. So here we want to do it in another way, where you say, okay, for, let's say, PP dict is basically a dictionary for power plants where you have them separate. So again, we need to say PP1, and then it's the first one. I'll just copy paste them just to be quick. 2, 3, 4. So now if we check this one, it's basically a dictionary of power plants where if you access, let's say, the first one, PP1, see that it is basically a dictionary of dictionaries. So if you say the type of this one, it's a dictionary. And when you access the first key of it, it's a dictionary. So basically you can put a dictionary inside a dictionary and so on, so that you can save your data in a very, very efficient way. I left the fifth one just to show you if you want to add another entry. So let's say a fifth key in this case, what would happen? So let's say this one, how can we access any one of them? So PP1, of course, the keys, even if the key was, let's say, a number, you can never access it without single or double quotations because it's a sensitive case. So we can access it like this. Let's say we want to add a different one. And then we say, okay, this equals PP5. Let's say we want to change it. So we want to make the first one to be the ROR power plant and the last one to be the solar. How can I do it? Pretty manually in this case. So we said we want the first one to be the ROR, which we defined here, and we want the last one to be the solar power plant that we defined here. So just wanted to show you that it will work basically by having the first one to be ROR and the last one to be basically solar. So basically using a dict is a very efficient way of storing data or even later on to iterate over data. Two last things I wanted to show in dictionary. Of course, we will go through them quite a lot. So one is how can I remove a key out of it? So we said previously we can access it like this. So let's say I want to remove the one with gas. I hope it was 4, I'm not sure. So it's this one. So how can I do it? Simply by delete. So if I do it again now, 3 and 5, so 4 is gone. To double check because it looks messy here. So with the keys we have PP1, 2, 3, and 4. One thing that, or let's say last thing that I did not want you to understand from this one, or from explaining the dictionary, they don't need to be identical. So we have a dictionary power plant. We just defined it like this. We wanted to make it identical as possible to make our lives easier. But we can, for example, add, let's say, a random key here. So another element, just to put 100, 500, 2, and then A, B, C, and then something like this. So it might be, it doesn't even need to be 5, the same length as the one before. So let's do another one even. So random 2. Let's just remove this 500. So it can be basically anything, and each key is somehow independent of the other keys. So we had keys that look somehow identical and nice, and you can read data from them, but you have keys like random or random 2 that you basically might never understand anything out of them. You don't even have to make, let's say, these keys as a list or anything. You can just put a float in there. Let's say 5.8. Again, you open it. So this power plant dictionary, if we say PP1, you can access this one. If we say 4, we don't have 4, so you will have an error because we removed it, if you remember. If you say 5, this one, if you say random 3, it's 5.8. You can even do some math on it. So let's say times 5, you know that this will not assign it to the value of the PP random 3, but it will make it. If you say times equals 5, then you will see that the value of it will change to be 29. So go back now again, it's 29. So I just wanted to show you how to play around with the dictionaries. They might be very useful. You might never use them. Depends, I think, on the preference on how you like to show your data. If you like it to be, let's say, more sophisticated, more organized, I like to use dictionaries for that. Uh, you can even use lists or tuples or sets. I think it's just a matter of preference. Sometimes you might be forced to use one data construction or data type over the other or collection over the other, but normally I think you would get the job done with any of them.